to enrich and enlighten ourselves. Without further ado, let's dive into our promising schedule. Our next session is on strengthening on CRT quality. This demonstration will showcase the rigorous standards that the wheelchair must meet to ensure they provide maximum benefit to users. Let's welcome our esteemed presenters. I would like to invite Mr. Mohanavelu, Scientist G and Associate Director, Biomedical Technology, DEBEL, Ministry of Defense, Government of India, onto the dais. I would also invite Mr. Chappal Kasnavis. He is a Senior Advisor for Assistive Technology at the Asian Development Bank, is a global leader in prosthetics, orthotics, and assistive technology. With 44 years of expertise, he has spearheaded major global initiatives, including the WHO UNICEF Global Report on Assistive Technology and the GATE program. I would also like to invite Mr. Soikat Ghosh Moulic. He is a senior orthotist at NHS Wales, UK, with extensive expertise in orthotic care. He also serves as an advisor for the KidStart project, focusing on enhancing healthcare services for children with mobility challenges. Now I'm going to invite Ms. Ritu Ghosh, Academics and Technical Director, Mobility India. I would also invite Mr. Raju, Assistant General Manager, Mobility India. I would request Dr. Anand Mhatre, Assistant Professor, Ohio State University, to share on raising the quality of wheelchair.
Okay, I'll go directly in. Awesome. Good morning, one and all. Good morning, one and all. I think I should start on the topic where one of the persons who joined us for the previous presentations, where they left, and that is repairs and maintenance. There's a huge need for parts availability, services, accessible rehab services, where repairs and maintenance can be conducted, right? And so what we are seeing on this slide, on the platform, is a common problem. Wheelchair repairs and breakdowns are so common. To give you a statistic, there is a research finding in India that when you start looking at complex rehab technologies, wheelchairs, knee, ankle, foot orthoses, you can also look at crutches, walkers, they break within 2 to 3 months of use. And that's very small time, that's very little use within which these devices are breaking. And you need them for everyday mobility. In fact, for many of the users, it would be getting out of the bed. You need your complex rehab technology, right? And so why do these wheelchair devices, complex rehabilitation technologies, break so often? And so these failures are exaggerated by the rugged conditions that we see in some of the less resource settings, but it also is there in high resource settings in developed countries. Additionally, the lack of maintenance resources, trained personnel, that complicates the situation as well. In rural areas, sometimes the place is so far that it is not accessible by rehab services, right? And wheelchair users, they suffer from frequent failures. When I say that, as I said, the person may have to stay in the bed or a regular chair in case their wheelchair is not working. Sometimes people, if we talk about children, and we are with the KidStart project, we want kids to start going to school. They won't be able to go to school. Adults, they won't be able to go to work, right? Simply can't access the society when the wheelchair is not there. Seating and positioning will become difficult if your tilt-in space mechanism stops working. That's how much the quality and reliability of these devices is critical. One of the research findings is that when wheelchairs break and people are having these health outcomes, which is staying in the bed, poor access to the community, that is when their health and function deteriorates. And when I say deterioration, it is also the place where they see pressure sores happening. People get hospitalized as well. And so this is research evidence that I'm saying that has been documented. And so the adverse consequences, they impact the user and their families extensively, negatively, and also pressurizes the public health. It's a huge burden on public health. Another outcome is that since repairs and services, those maintenance is not happening and parts are unavailable, the product gets abandoned. It just gets stop use. And so then the user and the family, they are waiting for the next wheelchair to come whenever it is available. Many of them are then looking for the donation camp. Where can I get just a wheelchair, right? It may not be the complex rehab tech, but just a standard manual chair because they want to have mobility. So to address this global issue, my research laboratory has collaborated across research advocates for adoption of International Organization of Standardization testing standards. These are ISO testing standards that test wheelchairs and other devices to minimum requirements, minimum quality requirements, and improve their reliability in the community. So my suggestion is that we should be developing more rigorous product quality standards for wheelchairs that are used in challenging environments. For example, one of the challenging environments based on what was shared earlier is the rural area where RDT serves. As part of the International Society of Wheelchair Professionals, I led the design and development of standards for wheelchair casters. And so what is the wheelchair caster? You see the front small wheels of the wheelchair. Those are the biggest pain point for wheelchairs. Those break the most often. And they break so often that, we don't have a testing standard for them. And when I say a testing standard, this is like mechanical test beds where casters are tested before they are put on wheelchairs. So what I did with my research is I put sensors on wheelchairs to understand how they are used in the communities of Kenya, Mexico, Baja California, all around the world I went to understand how these casters move up and down over bumps. And I simulated that on a test bed in the laboratory. And over a period of 7 years, I took time to develop the test bed as well as launch the International Quality Testing Standard for wheelchair casters. So if you guys Google today, ISO 7176-32, that has come out of my research laboratory. Thank you. So I'm known about wheelchair standards in India as well. We have the latest wheelchair vocabulary standard, right? So what vocabulary to use? We have standardized that. That's the latest standard. But the question is, what about quality, durability, and reliability, right? So we just found out later this year that India, the Bureau of Indian Standards, have adopted the full suite of ISO 7176 standards. And that is great news for us. And as part of the KidStart project that we have launched now a testing laboratory which conducts testing for two parts of ISO 7176. One is stability, the other one is durability, and my friend Soikat is going to talk more about that. And I hope that while we have established this laboratory, it pays for adoption of quality, the observation of quality in wheelchair devices as we go forward. Hopefully this lab is the machine that people can use and manufacturers, designers can use so that we can improve quality of wheelchairs. And hopefully that translates into not 2 to 3 months of use and wheelchair breakdown, but probably a year or more that can happen. So improving reliability as we use these standards that are available at Mobility India. I believe that it will significantly improve the quality of life for millions of people with disabilities, providing them with something which is a complex rehabilitation technology that cannot disrupt their life. They can remain mobile in the community. Thank you so much.
Sorry. Yeah, good afternoon. Good afternoon, everybody. So it's a great feeling to be here again. And Jaya introduced me as a part of NHS and all those things. I am the same wine in a different bottle today, that's all. Nothing else. And And it has taken me more than 25 years to come second time on the dais. and so here today, I'm becoming a little emotional though. So yes, so let's get back to the main subject. Wheelchairs, quality, service provision, complex rehabilitation, everything. It's a huge ball game, and I think it is a different world altogether, and it is an ocean of opportunities, and it is a never-ending process. And me and Anand were discussing that this is just the beginning of a different complex solution system that we are setting up, and we should not stop here. We should graduate, we should move on to the next stage. And when we were discussing it, it also reminded me that way back in 2018, 2017, when we started this discussion of this, and I always used to get worried about the children, the position of the children, and that's how it made us work a lot on different kind of positional devices. And we had a lot of evolution we have done on positional devices. And one of the parents, they said, who was using a twin device, which was another evolution of ours, that he said that how can we move the child who is sitting on a twin device. That's also was what prompted us that we think that how we can add more of mobility to this complex position of seating, positioning, and posturing, and that way. So, and that's when Anand came in, and he said that, look, we are going to have a call. Would you be interested? I do not know whether Kyoki is here somewhere. I saw him. I do not know whether Kyoki is here. Okay, Kyoki is there. And Kyoki is a very dear friend of mine. I always like him, love him, and in the right way, not in a different way. So when Kyoki, we got an opportunity to work with him way back. This project came up through CLASP, and for some reason it didn't materialize. So when Anand said that Kyoki will be a part of this project, so I was very happy that, okay, we will get another opportunity to work with Kyoki. And that's when the project started. And when we discussed that, okay, we need to set up a wheelchair testing laboratory, that was something very big, huge, enormous for me in particular, that I didn't know head and tail of it. But my first place of work where I was working, my manager, Mr. Raman Das, he told me that when you come across a problem, first say that, yes, you can solve this problem. So 50% of the problem is solved, so you're only left with another 50% how to do it. So I always follow his theory of approaching a problem. So I reduce the problem 50% right at the beginning. That's how we did. He said we can do it. It has been done somewhere in the world, so it can also be done here. With that mindset, we started working. And if you see the challenges that we got, Anand said that there are some good models of ISO wheelchair labs, but not in India. And so we didn't have any example, a good example of looking into that, what this lab would be, how it will look, what all things will be involved in it. And the next stage was we didn't have any access to the specifications, the design standards, the product standards, the material standards. So, I had very sleepless nights with that. There was no technical team locally available to work and coordinate with. I had gone to Mohan, my dear friend in DEBEL, spoke to Dr. CReaTe. He said that, yes, we can work out on certain things. So I knew that there is some backup for me. And, but we needed local solutions. Local problems need local solutions, local hand-holding. Another thing that we discussed, Anand, was that you require space where you're going to set it up. That was another project, and it has to be at the ground floor level. I cannot put it up on a ceiling or a roof. So with that thing, we started working on it, and we also got solutions. We got solutions, and luckily I came across very good engineering team, local engineering team, and as a prosthetist and orthotist, there might be many prosthetists sitting here. I had always tried to diversify my field and my networking, and that helped me to network with various other institutions, various other professionals from adverse and diverse fields. So I came across a good team of engineers. Anand sent me all the specifications for the lab, and we budgeted it, and we came across a plan. 45 days max this has to set up. 45 days max. So if you see the images, and you'll see the lab which is there, we started from scratch. We had to relocate some of the heavy machineries from some location to other after identifying the place, getting a consent from the designer, getting consent from the board, getting consent from my from Albina that yes, we can do it. We started setting it up, plan by plan, checklists, and we came across with basic 3 major testing facilities. As Anand said, that there are 32 standards, so we worked on major 2 standards with 3 testing. One was like the wheelchair stability testing, which is on the top floor, and it does not have too much of impact, but it definitely tests the positional stability of the chair when it is fully loaded, and at what is the tipping angle. We can mark and we can test and specify a product up to micro degrees, that this is tipping at this angle, so it is specified at that angle, which is often published by various manufacturers of how you specify your product. And it is a working model. We have tested more than, I think, 10 chairs on this now, and it is available still for any testing facilities. The most complex was this wheelchair fatigue testing, which is ISO 71768, which is a double drum test. And this is the most complex engineering, mechanical engineering, as well as electronic engineering, a combination of 2 engineerings, where we could get an engineer who was a master in sensors and electronics. So he, again, diversified certain spin-offs into it, made it more simple. In fact, when we were developing it, we realized that we are upgrading the whole ISO standards. We added more features into the standards that are there from ISO. If you see the side walls, the side grabs, they were not there as a part of the standards. We will see a scale that are not there as a part of the standard. So we do not know how much we are shifting. If the wheelbase has to shift, there is nothing to measure, but now we got that done. The cover for the motors, that is not a part of the standard. We added it. So ISO should thank us for that, for upgrading the standard. And this happened not by a design, it happened by chance while doing and with our involvement. So this is a working model which we'll be launching today. And another which takes maximum impact is the fatigue testing curb drop test. For testing a wheelchair, it has to complete a curb drop of 6,666 cycles of drop at the specified weight, which can be 80 kgs, 100 kgs, or 120 kgs. And with the dummy mounted on the chair, it is well aligned, and it will be dropping so many times. And if it fails, breaks, we stop, it automatically stops. We record the cycle where it has failed, inform to the manufacturer. So this laboratory is there to inform to the manufacturer, you pass, double drum, you have to pass 2 million cycles of rotation at 5 km/h speed. That is ISO standards. If it passes without any kind of breakage, without any kind of damage, it can be said that you have passed this 2 million cycle test, which qualifies for ISO 71768 double drum test. And if it passes 6,666 cycles of curb drop, it will say that it has passed. If there are any damage, anything, it will stop, and it will also specify which part of the wheelchair has failed. There are n number of parts on a wheelchair, depending upon what design. So which part is failing, it will say. So, like, we are very proud, like that, and I am personally very proud that I have been a part of this development, and we are presenting it to India and to the world. That yes, if you want, come and get the product tested, specified, it meets the standard before taking it to the user. So it is also kind of a culture that that should come into the market, that it come into the service delivery system. A product which is not assured of its quality, a product that is not assured of meeting the standards should not reach the beneficiary. It should happen before it goes to the beneficiary. I learned about this more when I was working with Bureau of Indian Standards. Tarun is also there. Me and Tarun had enormous discussions on various standard development. We submitted 15 standards, and personally I submitted, on behalf of Mobility India, we submitted a standard on wheelchair specific, on active wheelchair, because BIS had none. Today BIS adopted all the standards of ISO, which is a big thing. And so we realized that why standards, and what is the importance of standards, and how do you build it up? if you don't have standards, what can happen? We are talking about bringing an insurance sector to the service delivery model on assistive tech now. Without having standards and specification, no insurance will even bother to consider your case. So that is the first step towards getting things insured. And this we had been developing, we had been talking. Lastly, there is this small video, which Anand has taken a lot of pain to prepare.
That they are safe and reliable for use in the community. Users can keep rolling for a longer period of time. And that is exactly why we have wheelchair testing standards.
Now we'll start. Please start this.
In India, wheelchairs are rarely tested based on the International Organization for Standardization's guidelines.
That is why you see wheelchair graveyards around the world. When we test wheelchairs before they go on the market, we ensure that they are safe and reliable for use in the community. Users can keep rolling for a longer period of time. And that is exactly why we have wheelchair testing standards.
There are 3 tests that are set up currently in Mobility India. First, the tilt table test finds wheelchairs tipping angles. Next, the drum fatigue test finds the durability of the wheelchair against road shocks. Lastly, the curb drop test evaluates the durability of the wheelchair against curb drops.
When wheelchairs don't break, they don't disrupt the life of the wheelchair user. People don't have to skip work, they can remain social, and children can continue going to school.
Yeah, so that was about the wheelchair testing laboratory. Now I would ask Raju to take over from here, and he will share the next piece of studies that was done on this. Thank you.
Good afternoon, everyone. So I'm here to give some details of what we have done after setting up this ISO 7176 lab. So before going to that, I know many of you know sometimes joining and you're coming out and coming in. So this last 5 years, Mobility India, what we have done with the partnership, its project name is called KidStart. So under KidStart, majorly we have done 2 things. What you have seen, that one product there, Cub wheelchair, the technology bringing into India, and testing that device, using that usability of that wheelchair in our different settings in India. So that is the first thing. And second thing is setting up this ISO 7176 lab, wheelchair testing lab. So that was actually original plan. But after setting up with a discussion with, we have Anand sir and Soikat sir, and when we are discussing, then let's see how it works. So before going to the manufacturer and asking them to avail our services. Then we have come up with another small part of it, and a small study, and we wanted to conduct a study, and we have a confidence first. Yes, this is working. Then we can offer these services for Indian manufacturer or anyone neighboring countries. So that's why we have conducted a small study. I am going to give that report. Yes. So this study is mainly to identify, as you have seen, that there are 3 tests we are conducting. So mainly identifying the wheelchair testing, so durability and implication of wheelchair quality improvement, particularly in India. The purpose of our investigation was twofold. One is, we wanted to evaluate the wheelchairs prescribed in country through multiple channels. And other purpose of the study, as I said, was to test the feasibility of the ISO wheelchair testing jigs in the labs, how successfully we could carry out ISO 7176 tests. So these 2 ideas to identify. The study was involved in testing in 5 different wheelchairs, which grossly representing the commonly used models in India. So as last almost 2 decades, Mobility India we are prescribing, we know what are the wheelchair commonly we prescribe and give to. So we want to test them first. So these 5 wheelchairs we selected. Among them, 1 wheelchair is manufactured out of India, but still is available in India, the manufactured outside, and that we have selected. 3 of them, which is commonly available foldable adult wheelchair, and economically, low cost products. Usually everywhere is given. So the 3 products we have taken, one is outside, and one wheelchair we have taken a passive wheelchair, where that wheelchair rear wheel does not like that. Rear wheels does not have the bigger wheel or no push rims in that. So that one we have sent. Total 5 wheelchair we have selected, and we started testing them. The first test, as we know, the stability testing. Results indicated variation in wheel-based dimension and tipping angles across the models. So each wheelchairs perform differently. So as we know, that environment we use it in a different environment. So we need to, as a prescription person, we take a call, which environment, which device to be given, which stability wheelchair should be given. And some wheelchair tip easily, while those with a broader wheelbase dimension do not. It depends on the user's experience and use terrain. So that means the person's stability also we consider, and at the same time, the surfaces. Based on that, clinician can use stability results to decide on the wheelchair product and prescription. Second test, the durability testing results revealed that only 2 out of 5 wheelchairs, 2 out of 5 wheelchair, one is outside India, one is Indian wheelchair, but is available, pass this durability fatigue test. Notably, the study highlighted the challenges associated with premature wheelchair failure and emphasized the need for high quality requirements to prevent such failures. So one of the key takeaway from this study is the urgent need for wheelchair quality improvement, as last 2 days everyone were discussing, but with evidence we are saying now. The current design for folding and non-folding adult and folding junior size wheelchair are not sufficient to guarantee minimum qualities. The lack of standard adaptation is evident as a major contributor to the poor quality of wheelchairs used in India. The current national wheelchair standards in India until last year, dated back to 1991 to last year, have limitation in ensuring minimum quality standards. That is why we have 3 broken wheelchairs in this study. As you know, now we have adopted ISO 7176 this year. However, I have some good news. The Bureau of India Standards have adopted the ISO 7176 standards under the number IS 18651. And we can say that we have laboratory that can test wheelchair to these national standards. So before Indian BIS adopting this, so we have existing this lab now ready for us. So we can go ahead, if any manufacturer want to have, we can test it. Behind this study, we have already performed multiple tests. So 5 wheelchairs internally, what we ourselves we've done it, but 5 wheelchairs where manufacturers have already come and tested their product and they improvised their product. So that's how we have done around more than 10 wheelchairs. I hope more manufacturers and designers will benefit from this facility as they adhere to higher quality requirements. This will assist us in ensuring the individuals with the mobility challenges have access to reliable and durable wheelchairs. As sir was saying, durable ultimately, like whoever investing, insurance person or the family person or independent, investing some amount in the wheelchair, they will expect long duration products. At the same time, as India has adopted these standards, we should see some competition and innovation in the terms of design, quality, and reliability among the manufacturers, companies in India and neighboring countries. So that's another result we can get it out of this standard ISO 7176 lab. Thank you everyone for your attention. I think this message and this information will be useful for Indian manufacturers and as well as service providers and users. Thank you very much.
Now I would like to invite on dais Mr. Chappal Kasnavis to share his experiences, what he has observed in ISO 7176 testing lab.
Thank you very much for giving me this opportunity. I must congratulate Anand, KOK, Soikat, and the Mobility India for doing this. But the issue is much bigger. And that's where I think we have to really focus. What's next? You have done it, very good, but what's next? So I was chatting with Ritu as I was sitting beside her. I said, is this lab certified by ISO? Because if ISO doesn't certify your lab and you cannot certify then sustainability of this lab will become a big issue. So you have to really think big. There are very few ISO certified testing labs in the world, especially in the developing world. Even the developed world, they do some regional collaboration. For example, Sweden, Denmark, France, and Spain, they collaborated and they divided ISO TC 173. Okay, I'll do this test, Denmark will do, this will do Sweden, this will be done by Spain, because this testing lab is very expensive and you need a lot of resources to manage it. So what I will suggest that Mobility India should now explore with Ministry of Social Justice and Empowerment, BIS, and look whether this lab can be a resource lab for Southeast Asia or at least SAARC countries, because then only things can be sustainable. And to me, no standards, no future. Okay? Most of the India cannot export wheelchairs in the Europe. You'll hardly see Indian wheelchairs in the European market. Forget about North America, because there is no standards. Very few has a CE mark, but overall ISO stamps are not there. So you have to look into those things and talk to the government to see that how you can collaborate in this and bring different stakeholders together to do it. Because China, for example, has 2 testing labs, which I visited personally, one under Ministry of Social Welfare and one under China Disabled Persons Federation. So one country, 2 labs, and many countries has no lab. But why China has it? Because they want to corner the export market. They export 5 million wheelchairs a year. So they export 5 million wheelchairs a year. As a result, they need a testing lab. And when you see the testing lab, not only these wheelchairs, all kind of scooty, all kind of mobility, with little adaptation you do it. So that keeps the testing lab sustainable, gives the government money, and government is very supportive because they get the foreign exchange using the testing lab. So I think we need to think beyond, look bigger picture, and look for at least some national or regional collaboration to ensure that what we are doing that serves the purpose not only of our domestic market, also external market, outside market, and pitch the, because many things what I see across, it needs a lot of improvement. And product standard is one, I'll talk a little bit later, also the service standards, personal standard. Without standards, future is bleak. So please take this not as a criticism, as how we can see the bigger picture and how we can contribute in the bigger picture. And that's why we need to collaborate very much.
Chapal sir, thank you so much for that guidance. It's very helpful for the next steps. I think there is one thing that is missing, which is making the connection between the 2 projects that you have seen together. One is the Cub wheelchair and one is the testing lab, right? So Raju presented to you the testing study, but what's the opposite? So the Cub wheelchair that you see was ISO 7176 tested in this project, and that is the exact reason why we surveyed what happens after a year. We found that none of the parts on the wheelchair broke during that 1 year, and that is the exact reason why you need to have ISO tested wheelchairs in the community. I just wanted to make that connect. So thank you so much.
Now we move to the release of wheelchair testing lab brochure. I would like to invite Dr. Mohanavelu and Mr. Chapal Kasnavis for the release of wheelchair testing lab brochure. I would also like to call Dr. Carmen, Ms. Charu, Mr. Kyoki King, Ms. Albina Shankar to join the team and release the wheelchair brochure. Now I would like to invite Dr. Mohanavelu to share his thoughts on ISO wheelchair testing lab.
Good afternoon to one and all here, and I very thank much to the organizers to invite me as a chief guest here and to present to all of you. First of all, I'm thanked that I'm also waiting since last yesterday. I was in the dais but never been given a mic to talk. So first of all, happiness. So apart from this joking that I'm a different cup and saucer, so I'm going to give a different tea to you, not from entirely from your area, but I want to make the people who sits in a wheelchair to walk. So that's what I've been working for the soldier, also to the society. So what the spin-off from the DRDO that we work for assisting the soldiers. The soldier is not an impaired as we generally talk or we generally be discussing the last 2 days. He is a normal commando, normal person who needs assistance in the hostile environment, especially in the sky as a fighter pilot is flying. Or the submariner who wants to come out of the submarine. It's not like a James Bond, just like that come out, taking the hands of the heroine and just come out and float it. It's a very painful, it's a life, between the life and death. So the same soldier who is deployed in the hostile environment in the Siachen high altitude area, whereas an oxygen is not, there is hypoxia conditions, who has to be saved. So the sustenance of the soldier to be in a very normal livelihood and also to enhance his capability both physically and cognitively. That's the job that we are doing. But when we're doing for the soldier, it's equivalently important and it's being applicable to the society also. So I'll share some of my thoughts that which we work on this kind of an area, not entirely, but still some of the areas here. And to start with that where I think are left that ISO standards to be applicable for the testing laboratory of the wheelchair being deployed or being facilitated, going to be facilitated by Mobility India is that the first is that if you go for a CE or FDA standards, that's a Food and Drug Administration of US or the conformity Europe of the Europe, you need a two kind of a mandate. One is that the standards as you make the testing facility to standards for the functional requirements to be cleared. The another one is an ISO 13485. It's a quality management system of the manufacturer who does it also to be equally important, and the paperwork of that one. Then only it can go for a CE or FDA. And for the Bureau, for the Indian applicability, the BIS, the Bureau of Indian Standards, only formulate the standards. The CDSUO is the one who actually gives a certification for you to give the certificate, applicable certifications that you are qualified to give the certifications. Okay, so moving from that one, so I will talk about the little about my laboratory of the DEBEL, that's a Defense Bioengineering and Electromedical Laboratory under the organization of DRDO. And I'll talk that what some of the works we carried out with the passive orthosis, along with the IIT Madras and as well as to Mobility India, that's an above-knee process is called CADAM. You might have seen that, everything here. And then also some of the EMG-based bionic arm, and one of the flagship project of the DRDO, that is an exoskeleton. So that I'll be talking, and then also I'll go with a little move forward, way forward, what's going to happen or what's been happening around the world on this area. So I talk about my laboratory. My laboratory is in defense bioengineering. It's a unique and interdisciplinary defense lab, supports or they addresses the combat support and enhancement of the soldier's life at the aerial, aquatic, and terrestrial. That's in all three dimensions of the under the water, above the sky, and on the sky. So wherever you see that Indian map, the three sides being surrounded by the water, one side is in a land. So it's the peninsula of nature. So which makes that very difficult to live. So you can see that even the northwest monsoon, southwest monsoons keep on happening. And inside the jungles, deserts, one is the highest to Everest. So this making that the normal soldiers to live a normal day, especially the coastal environment, is very difficult. You might be knowing that DRDO is only for making weapons like missiles, tanks, as well as the aircraft. But the soldier who is operating, the pilot who is operating the aircraft, the soldier who is operating the tank, the soldier who is shooting the gun, is also to be safeguarded. So his life is at the stake. This is what that we are trying to protect the protectors at the utmost enhancement as well as sustenance of his life. If we take the statistics in Wikipedia also, if you see that the number of soldiers who died in the war is less than the soldier who is died due to inclement weather that persists in India. So that is the kind of the area, that the land demography that we have, for which we need to be protected. For that, what we have is that we have a complete an umbrella, like an university of all science and engineering, medicines, technologies to work together. And we work on space along with the ISRO for the astronauts, Gaganyaan mission, also the chemical and biological war weapons, also the crew protections, strategic systems like life support of the fighter pilots, submariners, and also the military exoskeletons. And also, whatever I said that earlier, the soldiers, whatever we do is applicable to the society also. So we have made, when our Honorable Dr. Abdul Kalam was the boss chief of our DRDO, he made a Society for Biomedical Technology, SBMT, which is the combination of the interministerial for the ICMR and the Ministry of Social Justice Empowerment, as well as the DST and DRDO, all five ministries together to make the Society for Biomedical to spin off the DRDO technology for the healthcare. So one of the product is actually, if you see that Kalam Raju stent was an earlier than above-knee processes, which we produced here and all. In fact, we made a ventilators also, the medical oxygen plant, OxyCare system, which was very applicable under the PM CARES during COVID first and second wave, which was done by our lab. And coming to the, what is an advancement of this, especially on powered orthotics and then the prosthetics for the rehabilitation is that I divide into two areas. One is that clinical rehabilitation, another is a functional rehabilitation. If you take in a clinical rehabilitation, it's your setup, which you do that when the patient comes, clinical assessment, planning, brainstorming, along with the engineers and doctors and technicians and orthotists and prosthetists. And you do the surgery and a manual exercise was to be done. You do the planning, you do the manual, or you do the gait trainer and clinical environment, you do that so that you get a muscle strength and it makes it everything inside the laboratory. What I am looking or we are looking is that to have a functional rehabilitation on a day-to-day basis. This kind of a setup that orthotics powered should not be only the lab oriented or maybe in a hospital oriented. We are looking functional, wearable, day-to-day activity to happen in the social environment and all-time support to happen 24/7 with the mobile app. And also you can get the social engagement, and what happens is that quantitative, a continuous assessment happens to the patient as well as to the physiotherapist. So this is what that we are looking for this one. So we, in that one, the main, as I said earlier, as a DRDO, we are not mandated to, or we are not completely for the society to be done. Whatever we develop for the soldier is as good as well for the society. So if I take it one of the product as you have seen, I don't have to describe about the kadam. It's an prosthetic above knee prosthesis. The 4-bar linkage joint rather than a hinge joint, which is made by indigenously by the IIT Madras along with the SBMT DRDO, as well as we done the complete clinical trials with the Mobility India, who made us our life is easy. We as an engineer, as a scientist, we sit in the very good room. We imagine, we taken the users as a granted. But when we come into the Mobility India kind of a setup, that we understand that our life, the real life is entirely different. The users are different. What the user wants is different. So we imagine, we design, we develop it is something is different from what exactly the user needs. That's what we learned lessons from Soikat and other friends from here, from Mobility India. Thanks to Mobility India for that giving an opportunity. For last 20 years we have been with us, and especially personally with me. And then we made this product available and we given the TOT to the Alimco. And they are also in the mass production of the sub-knee processes with the 4-bar linkage joint, and also to the Mobility India who producing this one on daily basis. And another one of the product is on the bionic arm, which we made that EMG control as equivalent as an world-class one, along with an institution here at local Bangalore in MS Ramya. With the engineers there, we made almost 10 years we continuously worked. We made this bionic arm to be placed easily, set up, and AI-based training can happen for 1 day or 2 days. Then it picks up the EMG signal from the residual EMG what's with the amputee, depends on his age and the thing. And then it trains immediately, hit him, and then a bionic arm starts working to take the bottle of the water or whatever he can want to do is doing. And it's not only for one hand, it's a both hand amputee also can use it, the same thing. So this is one of the things are made it. I'm not talking about the entire area. So I come to that, my cup of tea is on, today is on powered orthotics. That's an exoskeleton. The exoskeleton is in a robotic mechanical frame. It's called external skeleton. That's why it's called exoskeleton. That's a human being. We are an endoskeleton. We have the bones and muscles which contracts and makes that we to get a locomotion or any kind of a movement. So this exoskeleton is little different from the general robotics. People say it's a wearable robotics. It's a different from a robotics because the robotics is the one which can, particularly the humanoid robots or a standalone robots, works on its own, its input and output of video and audio signals. And if it is not working, you can recalibrate it. But this is the one which owned by the patient or owned by the normal soldiers, which has to work like a human structure, like a human functionality, on the human, and the same time the human works, it has to work. There should not be any delay between the human works or the patient works and the system also works. If there isn't even a delay between the millisecond between these two, it is not going to help the patient, it is going to actually lag him. It's going to load him. So that's a criticality, the challenges that these structures actually is being looked upon this one. So there is a two kind of exoskeletons we call. One is a passive, only with the mechanical structures, frames, joints, and the springs, etc., without any sensors, without any power. Mainly that's actually useful for the redistributing of the weight of the person where it is being get injured. So no need to again to reload it on the injured purpose. So you just reload or bypass the weight. Another is called an active exoskeleton or a passive exoskeleton, the powered exoskeleton, which senses the motion of the human, that's a patient's, and giving to the actuators or the motors, which works along with the human joints, and it gives an assistance for him to make a walk or make him move his leg and hand and all. So one is for augmentative, another is for the assistance. And if I have a mini classification, I can use it for the rehabilitation, I can use it for the soldier, I can use it for the industrial purpose, I can use it even for the doctors, radiologists who does hundreds of ultrasound on a day, who gets an injured with his the wrist wrist joint. So I can use it the lower part, upper part, or passive, active, or I can even use a brain controlled interface also of this kind of exoskeleton, how a human works. So move on to that various technologies. Are very simple because you are talking about the complex rehabilitation. So I thought that let me put into how complex this one. It is not easy to understand the human physiology, especially the kinetics and kinematics of the human body. So particularly the patients, each patient is the different. It's not that everyone is everyone is unique. So understand the biomechanics and musculoskeletal injuries or the musculoskeletal modeling and simulation, put him into these muscles because each person's muscles forces are unique. So how to quantify these muscle forces and put him into the modeling and simulation and make a wearable technology so that a person moves the system, the machine also understand what kind of movement it does in all 3D planes, on all 3D sagittal and transverse and frontal plane. And then make that whatever he wears it, that should not load him. And also whatever he wears extra as a payload also should not load him. So make him to transfer the load of the entire structure. then making the neuromuscular control along with the structures. So the structure also to work like a human, on the human, at the same time as a human. And integrated everything, it looks fine as a robotic system, but when you put onto a person and starts making it, especially if he's a normal person, it's very difficult. At least if he's in a paralyzed, maybe in a hemiplegic or a paraplegic, you put onto the person to work, then it's become easy for taking as a load of the patients, which is already doesn't have the control on his limb, whether it's a leg or a hand, and make him to work, it's a little bit of easy. And some of the products which we developed already in the DRDO and then also inducted into the sole users that I will take you. One is in a passive exoskeleton. It's only a carry for the 4.5 kg of the weight. It can carry up to 30 kg of your payload back. And it can directly benefits to 50% of the weight is coming to the ground. So you take only 20 to 30% your spine. So your LS51 is being saved. For most of the compressive loads come to the LS51. So it prevents that any acute or chronic musculoskeletal injury happens to these soldiers. And this we wanted to use it for the rehab, especially is being accepted already by, you can see that even videos, the person can even play the shuttle, badminton. So that is a kinematic compatibility and kinetic compatibility that he has it. So this we can use it for the hip joint damaged by the arthritis or the fractures and problem associated with the aging also. So any kind of a muscle entrophy or a muscle problems that we have, that we can try to use this with passive. So we are already open for this one. Another is a powered one, is a knee powered separately or could be in a waist powered separately. As you say that, as I said in some of the slides back, I have shown you that the Locomat, which is a treadmill-based system, which actually a complete full body suits. So you have to program the entire body, entire joint system, which we made, as I said, a functional, wearable, affordable, so that only the joint, the problem is, whichever the joint is having a problem, as in a waist or a knee, you put out only that part and then make him. But anyway, we done it for the soldiers to carry more weight, to walk in the upslope or downslope, but the Siachen areas and high altitude mountain areas, but which can be equally being used by the, or can be used by the rehabilitation purpose. But what moving on that one is that basically we get the signal from the brain and the neuro, then comes to the muscular. Then when the muscle starts contracting, then the endo, that is an endoskeleton, that's your brain starts moving, the locomotion happens. But if you see how that this kind of a powered orthosis works is that it picks after the movement is being done by the person or he wants to do that, then it goes to give it to the actuators and trying to match the natural human joint movement with the actuators or the motors movement. So there is definitely a delay. One is the top-down approach, another is a bottom-to-top approach. So to avoid this one, what we try to do is that to take in a brain control signals. The brain signals takes what it thinks, can also be given to the persons or the structures to start moving along with the human. So that's an area that we are looking into, area where we are working. And also that rather than a motors, can we have an artificial muscles, a synthetic muscles as like in a natural muscle, so that it can start put onto the three-dimensionally work like as in a natural muscles to work. So this is some of the example which we done with our collaborators. You can see that a person moves his leg, the wheelchair can start moving left and right, and the way that he wants to move from the flexion and extension of the thing. And same way that even if the muscles cannot be worked, arm cannot work, he can move with an EOG, that's an oculography. Even his eye movement, eye rash movement can able to make a left and right movement of the wheelchair can stop. And next one, that is the person thinks is a motor imagery. The person thinks that she wants to move on left, right, and the wheelchair can move it. So if he cannot able to move the muscles, flexion extension of his arm or a leg, or he cannot able to move even eyes, then he only think. The thinking process can be controlled into robotic control actions of this wheelchair movement. Beyond that, I put some of my PhD students or my scientists on this job is that it is not only that the exoskeleton or the robotic control can able to make the person to move and walk. Can I give a non-invasive brain stimulation at the time when he thinks motor imagery to happen that yes, I wanted to move? Can I give a kind of a brain stimulation if there isn't a problem in the brain? Or can I give an FES, functional electrical stimulation also along with the muscles so that it can match with the coherently with the robotic control also? So this is that area that which the researchers we are moving ahead, not only that to walk, while walking, whether the brain and the muscle stimulation also can happen with a small amount of current to contract, and cohesively it has to match with the exoskeleton, that is the powered orthosis to move on. So coming to the challenges, what to build we faced here is that the high cost is one of the area which we, it's being hampering. As a wheelchair, itself is not an affordable or which being costing. So we just to make the affordable this powered orthosis. For that, what we need is that the the low TRL, that's a technology readiness of the motors, encoders, and the gearboxes, battery packs, which makes them to more and more thing. I think it's like in a mobile. This can comes to an easily and affordable or a low cost. I think this is going to be a daily thing. If I recall one of the article actually when I studied how the mobility is very important for a person is that there was an article saying that in 1980s or maybe that the globalization started in 90s, how the females started the freedom, the movement. When asked the questions, a lot of people thought the answer will come is an employment, money, or a freedom in the family, society, many things come. But the right answer or the more answers which come is that right is that when females started using scooty pep. When they started scooty pep riding on Indian roads, they felt more freedom than the money, employment. So that is that, yeah, I think Madam Albina Madam also started using scooty pep. So we never thought that the mobility makes a person to feel free, independent. So the mobility to happen to the people, our people, is given a different memory to us today. And I'll put all my scientists to work, see that this powered exoskeleton to be a very affordable. Anybody can wear it in office, home, and start using, not only to come to all the time to the hospitals or in Mobility India's to start using that one. So lack of indigenous components is that our job to begin. Another is that the lack of clinical evidences, clinical trials among the physiotherapists, medical doctors, orthopedicians, neurologists, patients, and scientists we ask. This coherent and integrated approach to happen to get the continuous clinical data so that we start getting more and more the approach and more data which will help us to improve the design and development of the system and also to the treatment therapeutic point of view. With this, I stop and thanks for time for giving to share. Thanks a lot. Any questions? I'm happy to have it. Yeah. See, initially we also made like an Iron Man suit or avatar kind of a move. Okay, so hip joint is having a 3 degree of freedom, ankle is having 3 degree of freedom. I need to put it to the 3 kind of a motors. I make a bulky structures. That definitely the battery goes very high, and it's be useful only in the hospital. But if I want to make an affordable to be used in the social environment, it is not going to happen. So we divide into the modular approach. We don't want to follow the Iron Man or the avatar. So we made our own Indian band. So we made a knee powered especially based or only the vice based. So based on the joints based we made it. So as of now our system can work 4 to 5 hours continuously and the battery charging is time for 30 to 40 minutes. But the battery weight comes down, the battery again keep on increasing the way that we have been inventing. It gives much more that we are expecting 8 hours or 10 hours to charge. And moreover, if it is going to be an affordable in the home or office, charging is always available. The problem only I face for the soldiers in this Siachen.
Same question to Soikat also. You mentioned that 2 million cycles of rotation and 6666 drop-down test. So how much time it takes to complete the 3, testing cycle for one wheelchair?
It actually depends upon how you're running the test. The lab that we had set up here, if you want to stop the test at particular end of the day, you can stop it, and we can restart it from the same point again next day. But if you want to do both the tests continuously, I think 4 to 5 days it takes. But we wanted to have that facility, where we got the electronics built up, continuous stretch, the lab will work continuously. If they want to come back, I think one of the manufacturers, he came back, I think, for 3 days. So he was monitored. He wanted to see that. So we stopped it. He came back again. He started it again. And that's how it runs.
So in addition to what Soikat said, so we one lab assistant has to be there all the time. So even if it fails at how the whole it is functioning, it has to be observed also. So that is very important. It also, how many manpowers we have. So there are factors, but whatever we have done, it has ranges between 5 to 7 days. working 7 days. We had to stop in the evening because we have neighbors also. The sound comes. So, and also the staff has to go. So that's how we have done.
But Tarun, when we were developing it, we had a discussion with this engineering group. So one of the engineers who was working with electronics, he suggested that there will be a mechanism, moment the wheelchair gets disoriented, anything breaks, it will immediately stop. So there is no lagging, or it is not that it will be thrown out, and it will stop then and there, and the cycle also stops. So we know exactly where it has stopped, so then we find the reason of the stopping. Whether it has moved out of the drum, or whether the caster has misaligned and gone, any angular changes, the sensor will stop, the sensor will disconnect. So that was those things are not as a part of IS standards though. These are all built up when we were developing, and we took these brains of various electronics engineers. So yes, even if though it is mandated that somebody has to be there monitoring it all the time, but for some reason, if he has just moved out, and even if it stops that time, it will be safe. I hope I have answered your query.
Yeah, thank you.
One question regarding EXO. Is it the clinical trial is happening right now, or is it still in the phase?
No, our EXO is trials happening for the soldiers. I have not programmed for the patients. So I am open to that, to use it for the patients. But as of now, all the trials happened accepted for the services. This
Only
Army,
the
Navy,
soldiers.
Army.
Okay. Any expected date when it will be starting?
No, I am open to have any kind of, I'm already talking to the CMC as well as Mobility India also, that I'm ready to put on to the patients. I talk already the ALC, Artificial Limb Centers in Army, AFMC, all are, talk with them, with me. So I'm just putting that soon there. We don't want to make it a marketing because we are not for that. So we just see that. But why I say that I'm looking for an integrated approach for the many places, not only one. The neurologist, orthopedics, and then the physiotherapist, as well as the orthotist mainly. Then also we scientists to work together to get the clinical trials of this data. Otherwise, it's not one-man approach.
Absolutely.
One system is going to help me for everything.
I just take the opportunity to just let you know, this gentleman, Mohan, and that gentleman sitting there, Dr. Sripati, they are gems. They are diamonds in our society. One of the...
I think it's a due for lunch, I think. Sir.
One of the most humble people I have met. Blessed to have friends like them. And this gentleman, you will be soon seeing him for the unmanned Mars project that India is planning. He is involved into the project. Same.
Oh, it's okay.
No, India should be proud to have.
No,
this
we
kind
work
of
for the
people.
Gaganyaan. We are liking the astronauts' health monitoring and then things that we are doing it. So we hope continue to work with the ISRO for the things and all. But I thank that the Dr. Sripati, who is a medical doctor sitting here, he is a program manager of the SBMT, who is our group both physically and mentally to guide us, and who is the forces. And we are very fortunate to have the friends like Soikat and Albina here in the Mobility India, because this is a place we learned. Actually what? Because in IITs, we are also graduated in IITs. We sit in IITs, we sit in the AC room in the DRDO, we work here. But yes, we travel to the Siachen, we travel to the borders. We also have face the problem, we see the face of problem. But there are the normal commandos who wanted extra to happen to their life. But here, we see the patients each and every day. Sometimes every time I come to Mobility India, I leave, I say that I'm blessed by the God. So this is a kind of the feeling we get, and the people who wets the hands with the patients every day, both physically and mentally. We learn from every one of you. That's what actually gives that motivation to us. And we are blessed to God that whatever we learned and we wanted to give back to the society, whether it's a soldier or a society, we are giving back. That's why we are blessed. Actually, thanks to actually he doesn't have to thank us. Actually, we should thank to you, because we learn from you only how to design the system. It's not that otherwise we imagine we make the system. That's what happens here, I think. But also we'll agree that we sit in the IITs, we design it. But when Sujata madam sends a PhD students here only from IIT, then we understand that real problem here and change the entire design, entire systems, entire materials. And we do again CAD-CAM and we do the FEM simulation and we change it. So that's how we learned. Actually, you are the one who gave that real feedback to us, what is the user wanted. Thanks to you.
Your humbleness.
Thank you, Dr. Mohanavelu, sir, for such a wonderful and enlightening presentation. Now I would request the team to proceed towards a wheelchair lab for inaugurating the ISO 7176 testing lab.
And I request all the members to be seated here because there will be a live cast. And I request the dignitaries along with Albina. Where is Carmen? Is Carmen here? Okay. Yeah, Carmen, Mr. Nagraj, Shripati sir, and so please do join us. Okay. And the rest members, please be seated here.
You can increase the slope. Increase the height. Yes. Hello. I just asked that whether this height can be increased, but it's only the.
This width can be increased depending upon the wheelchair that we are going to test, between the size of the back wheel and the caster. So there are different kinds of wheelchair. If you have to do a 3-wheel, and we can measure the dimension changes from the scales that we have, so we can uniformly move it because it becomes quite heavy.
Speed. RPM. How much RPM that? 70. Okay. That's equal to how many kilometer per hour? Or maybe 1 minute. So it will be around 1 kilometer per hour. Approximately.
Yeah, so we need to do this at 1 meter per second. The shocks that are received by the wheelchair, that remains standard by that. Okay? So this exposure that you get with half-inch bump on both the drums, that simulates 3 to 5 years of use that the wheelchair would see in outdoor environments. And so it's standard 1 meter per second, no matter which wheelchair you're using.
What will be the RPM? Increase or decrease? The kind of dampness or the bumpness you get, it will be the same. Or is it changes? The amplitude? Is it tubeless tire? Depends.
Yeah. So it depends on what product the manufacturer has shipped to you. You test it as it is, and then you report in your, so you publish it in your report that you give to them is that, okay, this is the product that we have received, test pictures, and then the test results.
Just the question is that, is this the only you are having, or in India is already having people of this?
Like with these features, there are test lab in, I think, as far as I know, one wheelchair testing lab in IIT Madras. But I am not sure whether they have this specifications or not. With this specification, we have this only lab that we have. There's no other lab.
I think with this laboratory in a service provision center, it acts as a third-party independent testing laboratory, so that these guys who are at Mobility India, they can be the gatekeeper for good quality wheelchairs and then provide them. I think that is the biggest thing that has happened with the testing laboratory at a service provision center.
Anyway, I think you've done a very good, tremendous job. Now keeping up, maintaining as per the standards, and then I hope that you apply to the central government and get the certification, CDSCO, and apply the get the certification that you are the testing, we are one of the testing agents in India, so that make a big impact. Congratulations, madam, to entire Mobility India, made a fantastic job.
Thank you, sir. Thank you, everyone. And now we can go to the main hall.
Anyone has questions regarding the ISO 7176 testing lab?
Whom to ask? Nobody. Yeah. Yeah. Hello, Dr. Anand. I just have one quick question for you based on your experience in wheelchair testing. So from scratch, it's kind of follow-up question to someone asked before. From scratch, if manufacturer has designed a wheelchair and they bring the first prototype to you and then it's going to break somewhere, how many iterations it will take it to pass? Of course, it depends on their design, but how much you have observed in your experience? How many times this needs to be done with physical prototype?
Once.
Only once?
So
it has to be done till it passes the standard, right?
Usually what happens is the product has to pass once, at least for the FDA. Okay, that is the American thing. Point being that the manufacturer comes with the first prototype, it's going to break. They are going to go back with the design suggestion, rework, revise the design, come back again, may break again or pass. Again, if they once again find out what is the failure mode, test cycles, hopefully it has improved after the first revision. But if it has broken, then again you go back to the to your revision, design improvements. May want to test a little bit with the user as well before you go for ISO 7176. But there are some iterations before it passes actually. So I've seen people doing 3 to 4 revisions. Sometimes it has a couple of cases the manufacturer has not come back because it's just that the best that they can offer. The biggest challenge is that we don't have a national standard that mandates it, right? So one thing that was said by some of the folks on the dais is that we want this to be mandated in some way. So probably CDSCO can adopt the Indian standards that's being taken up, the ISO standard, and they can mandate the observation of that standard for quality testing of wheelchairs. And so that will help laboratories like these to be used by manufacturers, where they can not only just come for ISO testing, but also for product improvement. Okay.
Yeah. Thank you.
Yes.
Just one more point. This standards lab should be as independent as possible. There should not be any conflict of interest. Alimco having their own lab, or I'm manufacturing wheelchair, I'm having own lab. This doesn't have any credibility, okay? It's a pure conflict of interest. So it should be a very neutral and credible, so that anybody gets certificate from them is a verified and authenticated. Because otherwise it has no value. Means if I make my products tested in my lab, who will believe me?
Great point, sir. Any other questions? All right. Thank you so much for attending. Is that?
I would request all the RCI registered professionals for a group photo to be submitted online. Everyone can come up to the stage.
Just you can go for lunch and come back at 2:50.
We will now break for lunch. After lunch, we'll have the session. Thank you.
2:50.
At 2:15.
All RCA.
I request all RCA members to join here for photo session. Quickly. Yeah, all the speakers of the day, second day over speakers, please join. And chief guests. Chapal sir? Yes, sir. So, Dr. Mohanavelu sir, please be available for photo session here. Soikat sir? Anand, we are here today. What's your name? Kamraj, are you here? Kamraj sir. Photograph sir, please join.